Hello friends, in this artificial intelligence class we are going to see some important 2-mark question and answers for third unit planning. Define planning in artificial intelligence. Planning is a process of deciding the sequence of actions. Planning is the process of deciding the sequence of actions that will achieve the goal while optimizing the overall performance measure. So what's mean by planning? Planning is the process of deciding the sequence of actions. We are having a list of actions, but all the actions should be executed in which sequence to reach the goal state. This is the goal state, this is initial state. Here in this environment we need to execute all the actions in a defined order to reach the goal state is called as planning. For any planning system, we need the domain description, action specification and goal descriptions. These three are important in any planning system. What are they? Domain description, action specification and goal description. Define the representation of planning problem. In the representation of planning problem, we need to represent the states, goals, actions and solution of this planning problem. First, we are going to represent the states. In the states, the world means environment, that is agent environment is composed into logical conditions representing various states. Each condition should represent different states, and the state is represented as conjunction of positive literals by using the first order logic language. So here we have to use only the conjunction of positive literal, and the literals in first order logic should be the ground term. We have to use only the ground term. There should not be any functions in that ground term, and any conditions about the world that are not mentioned which are assumed to be false. If we missed out any particular terms means we can assume that term is false term. For example, at Virat comma ground, that is Virat is at ground. It is accepted because we are here using only the ground terms. So it is accepted term. But in this example here at captain of cricket comma ground, that is captain of cricket is at ground. Who is captain of ground? Virat, isn't it? So the captain of cricket is function, hence the functions are not allowed. This is not accepted. Okay. And next one is representing goals. It is a partially specified state and it is represented as conjunction of positive ground literals. Again we have to use only the conjunction of positive ground literals, and a proportional state S which satisfies the goal G. All the states should satisfy G if S contains all the terms of G. Here this is the proportional state S and this is the goal state G. Here in the S we are having batsman and bowler and all-rounder, and which also satisfy batsman and bowler. So all the terms in the goal state should be available in the propositional state. The next one is representing actions. Action is represented using preconditions and effect. By using preconditions and effect only we need to represent the action. Precondition that should hold before the action to be executed, and effect means the output will come after executing an action. That is, this is the current state. Here we are going to execute an action, after we will get the resultant state. That is, if we want to execute a particular action, this action means how this environment should be. So this is called as precondition. How the state should be to execute this particular action is called as precondition. That will be explained in this precondition. And after executing this particular action, then how the state will be is called as effect. So this is sub goal, and sub goal may be the main goal also sometimes. Okay, so while before executing the action, how the environment should be is called as precondition, and after executing an action, how the environment will be explained in the effect. And next one is representing solution. Solution to planning problem is action sequence. Solution to planning problem is action sequence, and execution starts from the initial state, that is S naught, and every resultant state should satisfy its goal. Okay, so S naught to S1 means S1 will become a sub goal, and etc. And finally we will reach the goal state. Each initial intermediate state that should also a sub goal. And sometimes they may ask, how do you represent the action schema in planning problem? Action schema is nothing but the representation of actions, which is collectively called as action schema. And in this action schema, three things are very important. First one is action name and parameter list. Action name, that should be a unique name, and the parameter list which contains the ground terms, which serves to identify the particular action. So to identify the particular action, we should have a unique name of action and the parameter list, and this is otherwise called as the signature of action. Signature of action. And the next one is precondition. Precondition means which is a conjunction of function free positive literals. A conjunction of function free positive literals, and any variable in precondition that should appear in action parameter list. And third one is effect. In a conjunction of function free literals describes how the state changes when the action is executed. That is, after executing the action, how the state will get changed, that will come under effect. So in the action schema, we need to represent the action name and parameter list. Next one is the precondition, and third one is the effect. Define the partial order planner. And the partial order planner is planning technique that decomposes a problem into sub problems. We are having very big complicated problem, and this very big problem will be divided into many number of sub problems. This is called as decomposition of problem, and it designs several independent sub goals. So each sub problem is having its own sub goal and solve them with several sub plans. So to solve each sub goal, we are having different sub plans. It generates various sub solutions for respective sub goals with the help of sub plans, and then combines sub plans to achieve the whole plan. The all sub plans will be combined together to achieve the main goal, which is the solution plan for the original problem. So in the partial order planner, we are going to compose the problem into sub problems, and each sub problem we are having several sub plans, and all the sub solutions will be solved separately by using sub problems, and then combine the sub plans to achieve the whole plan. The whole plan is called as the solution of original problem. List the difficulties in planning problem. Here we are having three different difficulties. First one is impact of irrelevant action. Second one is choosing the better action, and third one is decomposing sub problems. And first, the impact of irrelevant action. It can put the agent in infinite loop while searching for required actions. And these are not incorrect actions, but this makes no sense, and sometimes the system become more complicated. So while selecting action, we have to select only the relevant action for that particular state. Then only we can easily achieve the goal. And second one, choosing the better action. For this, we need good heuristic function, and it fully depends on the problems. Because for every new problem, we have to design the new heuristic function. And third one is decomposing subproblems. If a problem is decomposable into various subproblems, it becomes very easy to achieve the goal. But the agent should understand the decomposition attribute of the problem, and this is very difficult. So the difficulties of planning problem are impact of irrelevant action, choosing the better action, and decomposing subproblems. What is partial order planning? The partial order planning is otherwise called as POP. The POP works on several subgoals independently. We are having so many subgoals here. The main problem will be divided into so many subproblems. Each subproblem should have a subgoal and solves the subgoals with the subplans. All the subgoals will be solved by using the subplans and combines the subplans. All the subplans will be combined together, and flexibility in the ordering subplans, and there is no fixed order to arrange the subplans. And next one is least commitment strategy, that is delaying the choice during the search, and if there is any delay in between, that should also be acceptable here. How to define partial order plan? So to define partial order plan, we should have a set of actions that make up the steps of plan. So we should have a set of actions, and next one, a set of ordering constraints. Ordering constraints. Here we are having A before B, that is the state A should come before state B. This is called as state before B. And a set of causal links. A set of causal links, that is A achieves P for B. A is a state and B is the another state. To achieve this B, A should satisfy this precondition. A should satisfy this precondition. For example, this is right socks and this is right shoe. When we place right shoe here, this right sock should on. This is the precondition. If this particular state satisfies this precondition, then this is the resultant action. And the set of open preconditions. Open preconditions means if it is not achieved by some actions in the plan, that is called as open preconditions. So many open preconditions may also available in the partial order planning. The next one is planning graph. Planning graphs are very efficient to create a representation of planning problem. So by using planning graph, we can easily create the planning problem, and this is used to achieve better heuristic estimates and directly construct the plans. By using planning graph, we can directly construct the plans. And planning graph only work for propositional problems, and it consists of sequence of levels that correspond to time steps in the plan. The initial level is level 0, that is initial state. Each level consists of a set of literals, the set of actions that represent the possible at step in the plan, the possible steps in the plan, and it records only a restricted subset of possible negative interactions among the actions. In planning graph, each level consists of a set of literals. All these literals could be true in the time step, and which depending upon actions executed at the preceding time step. And next one is action. It is having a set of actions. all these actions should have their preconditions that satisfy at the time step, which depending on which of the literals are actually hold. That is, the literals are nothing but the name of the action and parameter list. So all this name of the action and parameter list will come under literals, and that could be true before executing an action, and the action means we should have their precondition. The precondition should be satisfied and then we will get the effect. So before executing an action, the state should satisfy the precondition, then we will get the resultant state. Friends, in this video I gave some important questions from third unit, and if you want to score more marks means you have to go through the textbook. Thank you all of you.